Supreetha. Welcome to my math class. In the previous lectures on limits and continuity, we studied something about if I have a curve. Okay, so this is x-axis, y-axis, x-axis and y-axis. Okay, and let me take a curve. So this is a parabola, right? If it goes something like this, it is a parabola. That is y is equal to x square. Correct? X-axis and y-axis. Yes. Now, what is the concept of limits? Suppose I have a point. Yeah, I'll take a point, say 2. Okay. So, what is limits? What happens to this function y is equal to x square? We are checking what happens to this function as the points is approaching towards this x tending to 2. We represent it like this, correct? X tending to 2. Yes, we even saw what happens when we take x as 1.9, 1.99 and values greater than 2. That would represent your RHL, which was 2.1, 2.2, and we observed that we got 4 itself. Correct. And moving on, we studied about continuity. What was continuity? We checked what happens when f of a, that is what happens for f of 2. Correct. When LHL is equal to RHL, we say the limit exists. Yes, when this is equal to this f of 2, that is f of a, we say the function is continuous. Now in this lecture, okay, let me study something about derivatives. Why do we study derivatives? Suppose you observe here, what happens for the slope of our graph here? Yes, take any 2 points, find the slope over here, something over here, something over here. As you can see the slope is decreasing. Yes, and if I have a graph something like this, say I had y is equal to x graph, okay, that would go something like this. But for this, the slope would remain the same at each couple of points. Yes, but for this graph, our y is equal to x square graph, the slope is decreasing and it is changing for each couple of points. At this point, the concept of derivative pitches in. Okay, what do you mean by this derivative? Let me take 2 points in the same graph. Okay, say let this point be, okay. Yes, so say let this point, I'll take this point and corresponding to this point. Okay, I'll take 2 points. Yes. Now, if this is my point A, then what would this point be? Suppose it has moved a distance h, this would be A plus h. Can I call my y as f of x? Say it is just a function of x. So this would be my corresponding f of a, correct? And this would be over here, it would be f of a plus h. Okay, what is this coordinate points here? It would be a plus h comma f of a plus h, and over here I would get a comma f of a. Yes. Now I would have to find, if this is my a, this is my b, let me find the slope of these 2 points. What is the formula? That is change in y. Yes, change in y divided by change in x. Correct? What is change in y? Change in y is f of a plus h minus f of a divided by a plus h minus a. So a and a gets cancelled, and this would be f of a plus h minus f of a. Yes, f of a plus h minus f of a divided by a. This is my del y divided by del x. The change in y, yes, the change, I am representing it as del, okay, divided by del x, that is change in x. So the final formula that I arrived at is del y by del x is equal to f of a plus h minus f of a, yes, divided by h. Okay, so if a and a gets cancelled, I would get here h. Yes, so let me solve a problem on this now. The given question is find the derivative of root x by ab initio method or delta method. Okay, I'll just do a little bit of changes for my formula. In place of a, I'll write x. Okay, what was h? It was a small change in x-axis, right? The small distance over here. So I'll change it as del x minus f of x divided by h is del x. Okay, so now they have given us f of x. What is f of x? F of x is root x. What is f of x plus del x now? F of x plus del x is, wherever you have x, replace it with what? X plus del x. Okay, now what is the formula? Del y by del x is equal to f of x plus del x minus f of x divided by del x. Okay. Now, what is our f of x plus del x? F of x plus del x is square root of x plus del x minus square root of x divided by del x. Yes. Now, how do we solve this? Always remember, if we apply limit del x to 0, we get d by dx of y. Yes, what is d by dx? D by dx is a symbol which denotes derivative of a function. That is what they have asked us to find in the question. Okay, so I would have to apply limit on both the sides. Yes, so even in the formula, to convert del y by del x to dy by dx, I would have to apply limit on both the sides. That is from del x to, that is del x tending to 0. Okay. Del y by del x is equal to dy by dx. Yes. So now, what do we have? If I apply the limit del x tending to 0, what would we get? We would get del x minus del x divided by 0. Yes, even in the numerator I have 0, so that would be 0 by 0 form, which is called as indeterminate form. We studied about this in limits. Yes, so what should I do now? I'll multiply and divide by. I'll rationalize the numerator. How do I rationalize? Yes, divided by del x. I'll multiply root x plus del x plus root x divided by root x plus del x plus root x. So clearly in the numerator I have a plus b into a minus b. What is the formula? That would be a square minus b square. Correct? So now if I square this, yes, a square minus b square root x the whole square, correct, divided by del x. I'll keep this term as it is, x plus del x plus root x. Okay, so we have the limit term as it is, del x tending to 0. Okay, so now what happens in the numerator? The square and the root gets cancelled. Agree? So what would I get? I would get x plus del x minus, even here the square and the root gets cancelled and I would have only x divided by del x into square root of x plus del x plus root x. Okay, so and we have this limit term in all the steps. Okay, yes, now what is the next step? As you can see clearly in the numerator, x and x gets cancelled. So I would have del x tending to 0. Yes, limit del x tending to 0. Here even del x and del x gets cancelled. Agree? So 1 divided by square root of x plus del x plus square root of x. Now I'll apply the limit. What would I get? Wherever I have del x, I would have to replace it with 0. So I would get root x plus root x. This is equal to 1 divided by 2 root x. Yes. Now moving on to our next question, that is, yes, find the derivative of x square plus 4x by delta method. They even call it as first principle method. Okay, so how do we solve this? Firstly, let me write down the formula, that is limit del x tending to 0 del y by del x is equal to what? Limit del x tending to 0, yes, del x tending to 0, f of x plus h, sorry, that is f of x plus del x minus f of x divided by del x. Okay, what is our f of x? They have given f of x as x square plus 4x. What is f of del x? What is f of x plus del x? X plus del x is what? Wherever you have x, replace it with x plus del x, the whole square. Okay, so minus, what is, okay, what is the formula now? Limit del x, or let me write that as dy by dx directly. Okay, so this would be dy by dx is equal to, okay, dy by dx is equal to limit del x tending to 0. In place of f of x plus del x, what do I have? I have x plus del x the whole square plus 4 into x plus del x, right? Because in the question we have 4x. So this would be plus 4 into x plus del x minus the question, that is x square minus 4x. This whole thing divided by del x. Try applying the limit and check that you would get 0. Okay. Now what should I do? Let me apply a plus b whole square formula. Try simplifying the polynomial in the numerator. A square plus 2ab plus b square, okay, plus 4x plus 4 del x. Yes, minus x square minus 4x. So minus 4x and plus 4x gets cancelled. Minus x square plus x square gets cancelled. Okay, and as you can observe, you can take del x in the numerator common. Agree? So I would get del x common into 2x plus del x plus 4 whole thing divided by del x. So we are free from del x in the denominator. We wouldn't get any indeterminate form. Now if I apply the limit, I would get 2x plus 4. Yes, so what did we study in this lecture? We studied how to solve or find derivative using, we call it as delta method, AB initio method, or even first principle method. What is the first step? Write down the formula. What is the formula? Limit del x tending to 0, del y by del x is equal to what? Limit del x tending to 0. Yes, even in the LHS, I would have to write limit del x tending to 0. Yes, first, whatever they have given us, that is the question f of x, find f of x plus del x. Okay, after that, substitute that in the formula. Okay, since we are getting 0 by 0 form, I rationalize the numerator. In the second problem, I tried simplifying the numerator. Okay, and then we try taking del x common or check if we can cancel del x directly. After that, we apply the limit and we arrive at our desired answer, that is the derivative of the given f of x. Okay. So yes, that is it for today's class. Thank you.